Hello and welcome. This is finally the periodic table. This table, I will use this table to explain a lot of things. If you're able to follow me from the beginning to the end, you will be sure of a lot of things. I promise you that. Some of you requested that I should teach metals and non-metals. You have metals and non-metals here, and I promise that I will do that using the periodic table. So this is the best means of explaining a lot of things. Here I will teach you even soluble and insoluble salts, reaction, bonding, a lot of things. So let's break chemistry down like this. All right. So now, in the beginning, you have this hydrogen, helium, lithium, beryllium, boron, carbon, and the rest of them, which you already know. Now, one good thing about this periodic table is that it has been arranged in such a sense that, look, if I have in one of the past questions, let's say an element X, we have here 11, we have here 20, 27, and here 13. So, in which group and period can this be found? If you have a question like this, in which group and period can this element X be found? Look at what you have to do. Just use what we call duplet and octet configuration. That is the 2, 8, 8 configuration. This thing I did here. So now, this is the first shell, second shell, third shell. When this one gets up to 2, it moves to this and moves to. So 13, let's configure 13. The first shell will be what? 2. Remaining how many? 11. So we can write 8. Remaining how many? This is 10. Remaining how many? 3. So 2 plus 8 plus 3 is 13. So now, the last number here signifies what? Group. While the number of shells, 1, 2, 3, that is signifies what? Period. So this one is group 3, period 1, 2, 3. Group 3, period 3. So let's go to group 3. See group 3, period 3. Look at it. See the elements here. So you always, when the question is asked, always configure it like this. So this is very important. This also helps us in what we call bonding and combination. This is called valence electron. The electron in the outermost shell is called valence electron. The electron in the outermost shell is called valence electron. So the valency of this element is what? 3. 3 is the valency. That is the combining power. So that is why we write aluminum like this. Means that it has lost 3 electrons. Let me show you something again. If you have, this is normal aluminum. This is 27, 13. So if it loses 3 electrons, it will be like this. Now, this number here, atomic number is 13. Proton number is 13. But number of electron, it has lost 3 electrons with what? 10. Be careful of this. So, under normal circumstance, it is supposed to be what? 13, 13. But in this circumstance, the electron is instead of 13 because it has removed 3. When an element removes electron, loses electron, it becomes positively charged. Just like electron is negatively charged. So if you remove negative, you become positive. So you will remove 3 electrons and now become more positive. So now look at it. If you have it like this, 13 minus 13 is 0. That is why we say an atom. An atom is electrically neutral. Why? Because number of proton is equal to number of electron. But if anything, if it happens that it gains electron, this aluminum, it cannot gain electron ordinarily. So it is supposed to lose electron. If it gains electron, it becomes negative. If it loses electron, it becomes positive. So now, if it loses 3 electrons here, so from 13 it loses 3, it becomes what? 10. 13 minus 10 is what? 3. That is why aluminum is what? Plus 3. Therefore, number of electrons, 10 here. Number of proton remains what? 13. Number of proton is atomic number. So, permit me to clean the board now. I will clean it, and having explained this, I will use it to say a lot of things about this periodic table. I hope you have gotten this. So some of these things are the things you see in the past questions. So let me clean this board and explain further. Group by group, period by period. Now at this time, I know you can now do this. 3 is 1. This is 1, 2, 3, 2 and 1, 4, 2 and 2, 5, 2 and 3, 6, 2, 4, 7, 2, 5, 8, 2, 6, 9, 2, 7, 10, 2, 8, 11, 2, 8, 1, 2, 8, 2, 2, 8, 3, and all of them. Now look at it. In group 1, all the elements have 1, valence electron 1, 1, 1, 1, 1, 2, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. In period 1, they have only one shell, one shell, one shell. This one, 1, 2 shells, 1, 2, 1, 2, 1, 2. Period 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Period 4, 1, 2, 3, 4, 1, 2, 3, 4. So period has to do with number of shells, and the group has to do with what? Valence electrons. Is that clear now? So let's now break it down accordingly. I will start with group 1 elements. After group 1, group 2, group 3, group 4, group 5, 6, 7, and group 8, or call it group O. So let's clean the board now. Alright, so look at this now. These are group 1 elements. So let's look at group 1 elements. I want to explain it, and let me just try to calm down and do it gently. These group 1 elements are called alkali metals. Many of you requested that metals should be taught, so let me teach metals. Alkali metals. Now, alkali metals, what is an alkali? An alkali is a substance that dissolves in an alkali is a basic hydroxide that is soluble in water. Sorry. An alkali is a what? Basic hydroxide that is what? Soluble in water. What does that mean? These elements, when we are talking of group 1 elements as metals, in this O level we talk about sodium and potassium. Sodium and potassium. This hydrogen is a gas. It's a gas. We consider it is here because of the valency, and it also is positively charged. So because of the valency, that's why it is here. Now, we most of the time talk about sodium and potassium. Now, before I come to this one, pardon me, let me talk about this hydrogen briefly. Hydrogen, water former. This hydrogen exists as a molecule, H2. In one of the past questions I saw, they gave them something like that. Which of the following groups has elements that can exist as molecules? So look, this position is hydrogen. It exists as a molecule. We know, and it exists, is a bit, I will just talk about hydrogen briefly, what we call isotopy. Isotopy means when there is different mass numbers. Different mass numbers, same atomic number. So there are 3 isotopes of hydrogen. Look at them. Hydrogen 2,1, 3,1, proton, deuterium, tritium. These are the isotopes of hydrogen. Same atomic number, different mass numbers. Now we know that hydrogen combines with water, with oxygen rather, to produce what? Water. Now, if I want to balance this, I will say 2 here, that is 2H2O. So 4. So it's correct like this. 2H2O. So this is hydrogen combines with oxygen to produce water. Now, in the laboratory, when this hydrogen is produced, most of the time you confirm the presence of hydrogen when you introduce a light or lighters or a splinter. So it makes characteristic pop sound. When it makes, if like this is a test tube, and I'm going to say something about sodium and potassium, and hydrogen gas is coming out like this. This hydrogen gas, when you bring light here, it extinguishes this light. It makes it to go off, making this pop sound. So when it extinguishes this light, in that process, it is combining explosively with oxygen to form steam. And there are many other things we can say with hydrogen. It is very reactive. It can combine with the group 1 elements as well to form something like this sodium hydride. So hydrogen, water former. when we have much time, we are going to discuss more about the elements, but I'm still coming to talk about it. So this is briefly about hydrogen. So when we talk about all these other ones, you will see how hydrogen is prepared in the laboratory and other things. So let's continue. Let's come back to this. All right. So group 1 elements. Now when I have their basic hydroxides that are soluble in water, that is alkali. They are called alkali metals. Why? This sodium now, if I combine it with water, it does not even require hot water. If it reacts with, let me write it here, this sodium plus water will give me sodium hydroxide. This is an alkali. Sodium hydroxide is an alkali. So when it gives me sodium hydroxide, it will liberate hydrogen gas. It will liberate hydrogen immediately as a gas. So if I try to balance this, so NaOH, so this is, I can put 2 here, 2 here. So how many oxygen do we have here? 2. I put 2 here. So it is balanced. 2 sodium, 2 sodium, 2 oxygen, 2 oxygen, 4 hydrogen, 2 plus 2, 4 is balanced like this. So this sodium, this one is aqueous. You will learn this in other soluble and insoluble salts. So now this sodium combines with this to form alkali. The same thing is done by what? By potassium. So I've told you the reaction of this alkali, these metals with water. So it does not require warm water because these elements are very, very, very reactive. Why? Because of this valency of 1. They have tendency to donate immediately. They can easily give out 1. So when they get all elements, all these elements you see here, they would like to retain what we call this duplet and octet structure, 2-8. They want to always remain like this. So the reason why they are reactive is because they always want to either gain or lose. Let me tell you something about gaining and losing electron. Watch. This one that is just 1, it can donate, so it's a metal. It can donate 1 to become only 2. This one can donate 2 to become only 2. This one can donate 3 to become only 2. This one can either gain 4 or give out 4. So if it gains 4, it becomes 8. If it gives out 4, it becomes 2. Now this one, it cannot give out 5. Rather, it will gain 3. When it gains 3, it becomes minus. Gaining of electron, as I explained. When it brings 3 electrons to this place. So if you add 3 here, it will become 2 and what? 8. So it becomes stable. So if they have this thing, that is what? Stability. That is what? We call it what? Stability. So this is, when it has 288, it is stable. It is stable. So now, see the same thing. This one, give out 1, give out 2, give out 3. Give or attract 4. Attract 3, 2, 1. These ones are stable. 288. That is why we call them noble gases. Noble. They are all reactive. Like this. They don't give out. They don't attract. They don't donate. They don't accept. So do not accept. It does not concern them. Now, the same thing is done by what? Potassium. Potassium H2H2O to give you what? Potassium hydroxide, an alkali, plus hydrogen as a gas. This is aqueous. Now, they react vigorously with water to give you hydrogen gas. That is why if this hydrogen, if you get sodium metal, put it in water, hydrogen gas comes out. Hydrogen is an odorless and colorless gas. So if you want to identify it, just use light. If you extinguish it, it means that it is what? Hydrogen. So this is one of the methods of producing hydrogen in the laboratory. Reaction of group 1 elements with what? Water. Now, let me tell you other things about these group 1 elements. Let me clean the board now. Okay, look at this now. So we'll continue. Now, let's go to other things about these group 1 elements. These group 1 elements are what? Soft metals. They are soft metals, which means they can be cut with knife. They may give you, which of the following is a soft metal? If you see sodium or potassium, that is correct. Why? Because of their valency of what? 1. Group 1 elements are called soft metals because they will give you options. The answer is what? They have valency of what? 1. Now, these group 1 elements, let's go to the other kind of their chemical properties. Okay, before I go into their chemical properties, they occur not in free state. They always occur in combined form. So if you want to get them, if you want to extract them, you must use what? Electrolytic what? Method to separate the other elements. So sodium cannot come out alone. Potassium cannot come out alone. Sodium mainly occurs as what? Sodium chloride, the common salt. So if you want to separate this chlorine from sodium, you pass it through an electrolytic cell. An electrolytic cell. This is another topic for another day. Put it in an electrolytic cell. Now let me generalize it now. This group 1, 2, and aluminium, these ones are separated and extracted by what? Use of what? Electrolysis, electrolytic method, because they are very reactive. This, and this. These 5, you use electrolytic method. But elements like the transition metals, like tin, and iron, and other ones, you separate them by use of what? By use of coke. Coke is a reducing property. This coke is carbon. So reduction action of coke on them will reduce them. This iron can exist as bauxite. We are not talking about these ones. We are just talking about the first 20 elements. So bauxite you can separate using coke to reduce, and the rest of them. All right. So we'll come back to this. Now let me show you other things. The triazo carbonate 4. This is very important. The triazo carbonate 4 CO3 of group 1 elements, they do not decompose on heating. When you heat them, they do not decompose. I'm teaching you to learn most of the things that have been coming out in the past questions. They gave them which of the following triazo carbonates does not decompose on heating. The answer is look for the group 1 triazo carbonates 4 of group 1. So sodium or potassium is the answer. I cannot remember the very year. So now, this one, what does it mean? It cannot break down to give you carbon 4 oxide. Unlike this group 2 elements. Let me just show you. CO3. When it decomposes, when you heat it, it will give you calcium oxide and carbon 4 oxide. But these ones cannot do this. So they do not decompose on heating. The only thing that will make them to give you CO2 is when any of them reacts with dilute acid. Then it will form what? Normal salts, then water, and carbon 4 oxide. So this is when they can give you carbon 4 oxide. So when they react with acids, they will liberate carbon 4 oxide, but on their own, they do not decompose on heating. I hope you are getting that. Now, the group 1, anytime you see group 1 elements, sodium or potassium, all sodium and potassium salts are soluble. They are always soluble. They readily dissolve in water. Group 1 salts, metals, their salts are soluble. So if you are asked which of the following is a soluble salt, check. If you see sodium or potassium, it is soluble. No matter the element, no matter the radical they come out with. Example, this one is insoluble. Look at it. This is an insoluble salt. It's an insoluble salt because CO3 salts, any salt that contains CO3 is not soluble, except when they are of sodium or potassium. So this one is insoluble, while these ones are soluble. These ones are soluble. Is that clear now? So these are the things. They are all there in the past questions. You don't need to be afraid. Both for UTME and for WAEC. With this, you are going to make good score. Keep following us. Keep watching this. Keep watching this. I know the reason. All right. So now, I've said a lot about this, and I've talked about when they combine with acids, like this one, when the triazo carbonates combine with acids. Now, on their own, when they combine with dilute acids, they readily displace. Let me use H2SO4. SO4. They readily produce what? Salts, corresponding salts, and what? And liberate hydrogen gas. And liberate what? Hydrogen as a gas. They will liberate hydrogen immediately. So if we put 2 here, it balances it. So this is sodium tetrazosulfate 6. I've taught students how to name this. This thing. Naming of inorganic compounds. Writing and naming them. Sodium tetrazosulfate 6. 6 is the oxidation state. I've also taught that now. So this is a normal salt. So when group 1 metals react with acid, they produce normal salt and liberate hydrogen gas. Right? I don't think there is any other thing I am forgetting about this. If there's any other thing I cannot remember, maybe in the course of explaining group 2, I will remember it and still talk about it. So now let's go to group 2. Let's clean the board and quickly go to group 2 and group 3 and see how far we can go with this. So look at this now. We are going to group 2 elements. Group 2. They have 2, 2, 2. We have magnesium and calcium. The magnesium and calcium as well, they occur in combined state with other elements. Magnesium can occur as in Epsom salt. Epsom salt. Now assignment. What is formula for Epsom salt? Epsom salt. Put it in our comment section. Epsom salt. Okay, another assignment. Now this sodium and potassium, they can bond. When they bond in air, what color does sodium bond with? Very important. Very important. Sodium bonds with what characteristic color? And potassium bonds with what characteristic color? In fact, when sodium bonds in air, anytime you say bonds in air, put oxygen there, it will form sodium oxide. So this one can be 4 here, so that we can put, the space is small, 2 here, 2, see this is sodium oxide. So when it bonds in air, produces sodium oxide. So what color? This is a base. This is what we call base. The other one is alkali. This one is a base. This is a base. A base. The other one alkali. So now you are even learning acid, base, and salt under this topic as well. Can you see that? Alright, combine. So these ones occur in combined forms. I've asked you to find the what is Epsom salt? What is formula? Magnesium what? So now let's come to they are stronger in form than sodium and potassium, but they are not as reactive as sodium and potassium. I hope you can understand that. So now look at this. Okay? Now let's start with when they bond in air. Another one. So you're going to give me magnesium bonds with what color? Calcium bonds with what color? In fact, let me give you a kind of option. One of them bonds with brick red flame. One of them bonds with lilac color. One of them bonds with golden yellow flame. Find out which one. Alright, so when magnesium bonds in air, it gives us magnesium oxide. This is a base. So we have 2 here. So 2 MgO. The same thing with what? Calcium. So it gives us 2 CaO. Calcium oxide is called quick lime. It's called what? Quick lime. This is quick lime. While when you add water to calcium oxide, when you add water to calcium oxide, it gives you what? Calcium hydroxide. Calcium, let me write it like this. Plus water, let me write it. Plus H2O. It will give us what? Calcium hydroxide. This is what? Slaked lime. Calcium oxide, quick lime. Calcium hydroxide, slaked lime. So get it now, lime. Quick lime, slaked lime. So now when they bond in air, to form what? Bases. These are bases. Now watch. Let's do it here. When they react with water, there is a difference here. In these two, we are talking about this. You must ask me beryllium. So in O level, most of the time we talk about this one. So let's concentrate on we don't have much time. So magnesium and calcium. This calcium, watch, in the electrochemical series, this one that has 2881 is stronger. It's more reactive than this. This is more reactive than this. This is more reactive than this. This is more reactive than this. Now, but when it comes to non-metals, the reactivity changes. This is more reactive than this. This is more reactive than this. This is more reactive than this. Take notes. So from metals, up like this, down to up, down to up. Non-metals, up to down, up to down, up to down. Take note of that. Thank you very much. Now, look at this. When we say this one is more reactive than this calcium can react with cold water as these ones do. When it reacts with cold water, it will give you calcium hydroxide, which is this slaked lime. Calcium with cold water will give you this one. But when this magnesium reacts with cold water, it cannot, because the magnesium hydroxide formed is coated by the what? The alkali. It's always coated. So when it reacts, what is needed that this thing will react with hot water. So when magnesium reacts with hot water, it will give you what? It will give you what? An alkali and liberate hydrogen gas. So when we have magnesium like this, plus hot water, you boil it, it should be hot water. Will now give you what? Magnesium hydroxide and liberate what? Hydrogen gas. So if we try to balance it, this is, we have 2 here. It is even balanced like this. So 4, 4, 2, 2 is balanced like this. So magnesium reacts with hot water to give us what? An alkali and what? A base, and this one. So now look at this. So we have talked about when they burn the air. We have talked about reaction with water. When they react with dilute acids, they will give you what? Salt, and also liberate what? Hydrogen. They react with acids to give you what? Salt. This is a salt. Some of you will say, how come? It's a normal salt. We may still learn acid base and salt. If you desire that, just let us know, but I will teach it. But it's not, I'm not sure it is within this short period of time. Alright, so they react with dilute acid to form salt and also liberate hydrogen. As I said the other time, their triazocarbonates, they decompose on eating to form a base and liberate carbon 4 oxide. And their triazocarbonates 4 also react with what? Acids to produce what? Corresponding salt, water, and carbon 4 oxide. See, if you can understand this, just picture it as it is. You will always be able to. In fact, watch this video, watch it and watch it and watch it. Go through it a number of times. Even when you are in higher institution, keep checking this. It will help you. It will help you a lot. It will help you. Now, I think we have touched this group 2 elements. So now this group 3 elements, I just have to tell you the same thing. You extract them by electrolysis, but we are going to talk about aluminum. Look at this. You can have aluminum oxide, but this does not exist. This is the only thing I want to say in this. Aluminum triazocarbonate 4. This does not exist. Past questions. Which of the following does not exist? What is the answer? This. Aluminum triazocarbonate 4. AlCO3. Al2. CO3. 3 rather. Al2CO3. 3. This thing does not exist. It doesn't exist at all. This thing. So there is no aluminum triazocarbonate 4. Go and find out why. But now let's continue like this. Alright. Now these ones, carbon and silicon, these are metalloids, semi-metals. This silicon is used as a semiconductor. Silicon and germanium, semiconductors. That's what we may discuss in physics. The semiconductors, holes and carriers, electron carriers, and the rest of them in physics. We may talk about that one. So now, carbon and silicon in group 4, they are either plus or minus 4. Plus or minus, they can gain 4 or lose 4. Carbon 4 oxide. So it has variable oxidation states, right? So I think this is where we have to end it, because when we are talking about carbon, this one is deep, is wide. I have to say a lot under this and just a little about this. So this carbon, I want to treat it as a topic fully. Now these non-metals, let me just say briefly, because of some of you that have exams tomorrow. These ones, this oxygen exists as diatomic substance. Oxygen, diatomic. I'm just trying to tell you the things that come out quick most of the time. Diatomic, O2. This oxygen gas can be produced by thermal decomposition of this substance. When you heat it, you get it. And other substances like this, when it reacts with HCl and other substances. Now this oxygen gas, it rekindles a glowing splint. I'm trying to bring out some of the things that come out in the examination. When oxygen gas is coming out, let me say we are heating this in. Oxygen comes out here. Unlike hydrogen, hydrogen will put off the light. Hydrogen will put off this light. But oxygen will do what? Oxygen will make it to glow. It rekindles it. And if you want to test for presence of oxygen, this is just like I've specified here now. So oxygen is colorless and odorless. Or colorless and odorless. There are many other things. Sulfur and other things. Then fluorine, these are called halogens, the salt formers. They have bleaching properties. I think I have to call it a day here. Let's just end it because of the time you are having there.